Are you curious about who Lizere is texting to? Without grabbing her phone, we have better idea.
Nice.
So let's move to our network traffic analyzer. So first, let's walk through our traffic analyzer project agenda. So first is our project overview, and then the second part is our design choices, and the third part will be our personal contribution, and the fourth part will be the demo and the implementation. The last part will be the conclusion of our project. So the project overview is the goal of this project is to develop a tool that can analyze network traffic. The input to our analyzer is a hex dump text file containing bytes of multiple packets. The analyzer will decode various protocol headers such as Ethernet, IP, UDP, DNS, and DHCP. The output will be similar to the information provided by Wireshark in the packet details pane. So talking about our design choices, so we used Python for its ease of development, and we structured the program to be modular with separate functions of parsing each protocol header. So this made the code easier to maintain and extend. So talking about our personal contribution, Yizhen was in charge of building fundamental structure of the code base. So she wanted to ensure that the whole project had a solid framework to build upon. So she wrote the basic code for each module, setting the groundwork for the entire project. And she's also in charge of editing the 10-minute video presentation, ensuring it effectively showcased the project key features. Lizere has been dedicated to refining the front end, focusing on making it visually appealing and user-friendly. She also in charge of working on the draft of a comprehensive README and to-do guide, aimed at providing future users with clear instruction for understanding and utilizing the project effectively. Since we encountered a lot of problems during testing our project, so we also debug together for the backend.
Let's get on to show you guys how to use our analyzer. So you will receive the zip file actually, and after you unzip it, you will get the folder. If you open the folder, actually the first you will see is these two folders. So you need to click into this one, and there is a bunch of files here. The really critical file is this one. So it's actually an exe file. And after you click into it, you need to wait for a few minutes for this user interface to jump out. So there are 4 buttons. The help one, it actually leads to the how-to file. So it will gives you a introduction to using our analyzer and some very detailed steps to initiate it. After you click the cross, there is another button called more information. If you click into it, you will see the README. It includes some tips, some highlights about our detailed descriptions, and there's a very, very detailed of our implementations. So the other 2 buttons are actually the things that we're going to use. After you click this choose file, you will need to choose a sample input. It is a hexdom file that is a traffic that we need to analyze. So it will show that you have successfully selected a file, and you click is confirmed. Then you will see like the decode now button is no more disabled. You click it, it will show that the file has been decoded successfully. And after you click confirm, the output text file will pop up automatically. So you will see that it has output of multiple packets, and between each packet there is a line, and the output are neat. They have field value, field name, yes, and including both hex and decimal. Is basically how our analyzer should be used. So let's get down to the detailed implementation of our source codes. The way how we structure the whole codes takes approximately 5 steps. The first step is that we realize that we need input-output structure. So the question is how we get these input and these output. The input from Wireshark, as we may know, is messy, as meaningless marks. So we need to find the order by list slicing, so we can get a hex dump files with only the hex codes that we want. The way we get a neat output is by using nested dictionaries and only lists, but not nested list in the output data structures. The second step is that we realize that we need to divide different packets in the whole files as mentioned in the requirements. So then we know that for each packet, we need another function that take control of the whole parsed packet. So it's basically a hierarchical structure. And for in each packet, there is another parallel structure since there exists 4 layers to analyze Ethernet, IP, UDP, DNS, or DHCP. So then we come to more accurate calculation and counting. An interesting and annoying stuff we encounter in the coding is that the difference between bytes, bits, and hex during the calculation is hard to avoid mistakes. So when you do list slicing, you have to be very careful. And the very last steps, we do verification and we find packets from the Wireshark official websites. They provide some simple traffic captures. Let's go to the source code structures. So as long as we have got a single packet, Ethernet and IPv4, they are very easy to implement. Respectively, need list implement and dictionary. So UDP is a hard thing because the last part as DNS or DHCP is largely dependent on the UDP port. So what we do is we put DNS and DHCP actually a part of UDP during the implementation, but for ease to read, in the output we put UDP, DNS, and DHCP in parallel positions. UDP header is easy to address, but DNS is the most tricky thing. Consider its complexity. We use DNS packet parsing to control the whole DNS packet in its header, DNS answer parsing for its question and answer, domain name parsing, and DNS authority parsing, which actually shares a similar structure with the DNS answer parsing and domain name parsing. DHCP is structure is simple. It only consists of header and option, but the header is very exhausting in listing out all the stuff, and option is just impossible to exhaust all possibilities. So what we do is we find out the most repetitive few options that appear in our lab packets, and the simple packets we find from Wiresharks, and we only do the detailed implementation of these. So let's go to the highlight features of our source code. The first is a nested try except structure to avoid crash in ignorance of unknown keywords. We start with the if-else sentence, but it turns out we never know in which detailed steps there comes out a strange keywords or what exactly the error is. So by the sentence except exception as E, we can clearly know what the error is and where it comes out. The second highlight feature is the ease to select any legal hexdump files with synchronizing selected file path into the coding Python file, which is the final.py. So on the top is the user py. In the choose file function, you can see that there is an attribute to the class that is called selected file, and this one is actually passed to the main function in the final.py. So it's actually an astonishing fact for me during the implementation that main function can actually take parameters. So by doing this, we achieve the synchronization of the file name. In this way, you can easily pick any legal files that you want to analysis as long as it's hexdump. Yes, and the very last feature is that the reuse of similar structure method with idea of modularization that I have mentioned before is that my DNS authority shares very similar structure with DNS answer and domain name parsing. And also in the DNS answer, because we know the compressed name is actually just the same of the corresponding question. So I just increase the numbers of parameter in the function so we can escape the function to get the domain name. That's very long and exhausting. And by just pointing to the variable, we get the result. I would say there could be 3 main improvements. The first is to allow for a drop-down menu without keys repeatedly printed in our output text files. If you go to our text file, you will see, especially in the DHCP options, because it is a list. Everyone can do a CML format, and I can do a fancy drop-down menu, like a real tree structure in the Wireshark. That will be better. Another improvement is more compatibility with DHCP options. It requires me more knowledge and familiarity with DHCP messages. And also the the very feasible thinking how to implement different list slicing to fit into the different formats. The very last improvement is more efficiency and less space occupancy. Honestly, our a lot of functions were done by adding extra variables. For example, if we want to tell when the DHCP option exhausts, there should be the offset, and when the offset exceeds the data length, there is a key error, and it tells us that the option has exhausted. These three are the main improvements I think we can do.